All right, so when we were sketching graphs yesterday, we sketched the one, right? Transformation. I said that one of the important things to do is to find the new y-intercept. And sometimes we can't find the actual value, especially when the base is e. But we just need to know if it's positive, negative, or zero. So that's what today's warm-up is inspired by, that idea. So it says to find the y-intercept. And of course, it's all about indicating our method, right? Communicating how we're doing it. So notation, notation, notation. So again, how do I communicate that I'm plugging or that I'm finding the y-intercept? Plug in a 0 for what? For x, right? And we show that by going g of 0. Super important. Now when I plug it in, I get 6 minus 7 times 1/2 to the negative first. Now that's an exact answer, but we could simplify it, right? We could do better. So let's do that. 6 minus 7. What's another name for 1/2 to the negative first? 2. Good. Right? We flip it. Yeah, we flip it. We don't make it negative. We flip it. Right? And now that's 6 minus 14, which is negative 8. There you go. So this graph crosses the y-axis at negative 8. Da, 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 da. Yeah, nice, 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 baby. Fineasy, fineasy. Okay. So let's look at Canvas real quick. Let's see, oh, that's wrong. There it is. Precal modules. Scroll to the bottom. Thanksgiving. Did it show up? Did Christmas show up?
Yeah. No. Yes. Christmas. Ho ho ho. Christmas.
Oh, ho ho ho. Yeah, yeah, yeah. Okay, mine doesn't show up. Why is that? I don't know.
Maybe Santa forgot. You're on the naughty list.
If it's showing up on y'all's, it should show up on mine. Yeah, let me restart.
The one with holiday math story and math.
Yes, yes, yes. Okay, while I'm trying to reload, let me just tell you about a couple of other announcements. There's only 12 days left because we're already into this day. School days, I should say, until Xmas break. Little Shop of Horrors is tonight, the first showing at 7 p.m. What a bargain, only $10 at the door. And if you miss it tonight, you can go on Friday or Saturday. And then there is a dance, a winter dance on January 22nd. It's at the venue at Creekside, and it's sponsored by the Parent Teacher Association of America teachers. Yeah, we don't know what time it is, so that's kind of a save the date thing. But I saw that yesterday, and some people are into dancing, right? High school memories made right there. So it'll probably be, I'm guessing, 7-ish. Probably won't be like at like lunchtime, right? But they are going to crown Snowball King and Snowball Queen, right? Instead of homecoming, because there was no homecoming dance. Yeah, happy Christmas lights day, everybody, and happy December. Okay, let me see if that gave it enough time to. Nope, still didn't show up on my end. I don't know why, but anyway, what you'll find in there is, of course, the assignment for the Christmas project. And what you're doing is you're essentially writing a Christmas story, okay, or a holiday story. I think it says on there it could be Kwanzaa, it could be Hanukkah, or it could just be about you know, winter break, right? Like we don't have to come to school, whatever. And you're going to include math terms in it. So it tells you how many math terms to include, and there's a rubric too, so you can see exactly what I'm going to be looking for as I grade them. Okay. And the due date is on there as well, right? It says the due date is when? Yeah, December 10th. Trying to find. Oh, those are not them. Let's see. I have some samples that I could read to you. Yeah. Here's some. Just so you can get an idea. So we'll do this one on the video. Here, I'll just read this one. This person went all out. So you do have to print it out. So we're not turning it in digitally. So this person went all out. They got construction paper, 2 pieces actually, and glued them together and then cut out their story. It has to be, I will be grading punctuation. I will be grading one of the content rubric criteria is how good. You don't want to just say one Christmas season, Mr. Corpia assigned us a project where we had to include whatever 25 words. And so I chose the following words, blah, 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 and you list 25 words. Merry Christmas, ho, 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 right? You get like, I'll just hand it back to you and say, you smart Alec, redo it. It counts as 2 quiz grades or 2 daily grades. So if you choose not to do it, I do drop 1 low grade right at the end of the 9 weeks, but you'll still be stuck with the 0. Right? Thought that one out, right? Because I've had people in the past abstain, right? It's like, we don't celebrate Christmas or holidays. So I'm like, okay, we'll have fun coming to school the 2 weeks while we don't. Ooh, ow, ooh. This one's called The Tale of Saint Nick. I'll read it to you. Oh, the Tale of Satan's Christmas. No, The Tale of Saint Nick. And all of the mathematical words are underlined in the story. That database that I gave you, the word bank that I gave you, database, is just a suggestion. It doesn't necessarily have to be the words you choose. If there's another math word that you know about that's not on the list, feel free to use it. But you do need to underline it when it occurs in the story. And you can't reuse the word. So once you use it, it counts as one. You got to choose a different word. So anyway, here it is. I don't even remember the quality of the story, but it's an example. Up in Santa's snowy domain, see what this person did? In an expansion of snow and frost, a jolly old man was having a nice pre-sleigh ride stretch. There's a math word. It was Christmas Eve, exclamation point. An important day for old Saint Nick. He was about to take flight. He began to accelerate in his sleigh, building velocity until the ice carriage reached its limit. Santa took flight at an angle of 75 degrees, which, as we all know, is the angle at which maximum range can be achieved, and curved upward. His speed growth was exponential. Was it really, though? Was it really? The more speed he had, the more speed he got. I think this person used it as an adjective rather than, or a noun, right? It was exponential. I don't know. I doubt it was a math term. They don't have to be used in a math context, right? And he flung him in his seat so violently, he had to horizontally shift on the bench. Oh. He flew over holes in ice and slopes of snow. Nice. Soaring parallel to the ground. The reindeers, put an S at the end. I didn't catch that at the time. Pulling the sleigh had such power. It was radical. Yeah. At last, Santa arrived to the suburbs. The mass of houses seemed infinite. As he popped inside the homes, compressing through the chimneys, he usually saw plates of cookies with the occasional ice cream cone or a pie. He continued delivering gifts at a constant rate. Finally, he finished with the last house and started home, cranking the volume on his sleigh and increasing the distance between him and the rest of the world. The end. Okay. So sometimes the stories just kind of drop off sharply at the end. It's like, and then because they're like, I got all my 25 words. I'm getting to the end of the page. I'll just end it right here. So try to have a little bit of, dare I say, a rough draft. Don't just like, and it does have to be typed. If you handwrite it, you're going to lose points. Don't just write the first one and then turn it in, right? It should be fun, right? Easy reading is darned hard writing. So put a little effort into it. It's not an English class, but grammar, commas, it's kind of the same thing as like math punctuation, right? You don't want to be misunderstood. We're trying to communicate. So there you go. All right. Any questions on that? That's due Friday the 10th. So you got about a week and a half. If you want me to like read it before you turn it in, I'd be happy to. Okay. And you can show me on your whatever iPad if you type it in whatever notes. All right, so we're picking up with example 7, and let's see. I don't know when we'll be able to finish. Maybe today or tomorrow. I doubt today. Maybe tomorrow, which means we'll probably quiz on Friday instead of tomorrow. Okay. All right. Questions before we start. All right. Letter 7. Sketch f of x equals 4 minus 3 times 7 to the 5 minus x. Give the domain range. Find the y-intercept. All that good stuff. All right. As we mentioned yesterday, step 1 is to identify the parent function. What is it? Is it e to the x? No. Is it even exponential? Ness, right? Yo. Ness. Yes. Yeah. It has a variable exponent and a numeric base. So the parent function is 7 to the x. 7 to the x is what? Growth or decay? Growth. So again, in your mind, if nowhere else, you imagine the parent function 7 to the x. So I like to sketch it off to the side. Now 7 to the x is going to look a whole heck of a lot like e to the x when you sketch it by itself, right? All exponential growth functions have the same look. It's only important to show which one's steeper when there are 2 of them or more graphed on the same grid, okay? So now, once we identify the parent function, now we need to put it into standard transformation form. And let's see if we could do that, all right? Step 1, I'm going to bring the 4 that's in the front to the back. So that's minus 3 times 7 to the, and then I'll put plus 4. Now, if there's work to do, it's going to be inside the function, okay? It's kind of the most labor intensive part of these types of functions. The first thing we want to do is put the x term first, right? Let's scroll back up here to yesterday. Remember, in standard transformation form, the inside part has to have the x term first, right? X minus c. And the coefficient of the x inside the parentheses has to be a 1. If it's not, then your horizontal shift is off. So if there is a coefficient in front of the x, you have to factor it out of both terms on the inside. Otherwise, your horizontal shift will be incorrect. So let's do it as a 2-step process. Step 1, I'm going to commute the 2 terms. Let's use a different flavor here. 5 minus x is the same as negative x plus 5. Okay, so all that did is put the x term first. And notice the plus 4 on the right, that's already on the ground floor. That's your d value. Now you ask yourself, is negative 1 the same as 1? No, it's not, right? So if your coefficient of x is anything other than 1, you have to factor it out of both terms. So let's see if we could do that. F of x is negative 3 times 7. Factor out the negative. That's going to leave me a positive x. And then what does that leave in the second term? Minus 5, right? Now factoring out a negative is pretty easy because all it does is change the signs. But remember, factoring out is dividing out, okay? If you're not sure if that's correct, do your math homework, the worksheet, right? You can quickly mentally redistribute, right? And if you mentally redistribute, you should get the line above. If not, you did something incorrectly. We got it, okay? So now it's in standard transformation form. I might have you on the quiz describe the sequence of transformations. Describe the sequence of transformations. So let's go ahead and do that. You can go from left to right. What is the negative in the front going to do? Let's number it because sequence is in order, right? Reflection across the what? X-axis. Yeah, we don't want to say flip. Flip is like a informal term that you use when you're talking with your friends at the math party, right? In here, we say reflection across the x-axis, or it's fewer words to just say x-axis reflection. A negative in front will always do that. That's what the negative part does. What does the 3 part do? Just the magnitude, 3. It's a stretch on the y's, right? So we say a vertical stretch, which you can abbreviate VS, vertical stretch by a factor of BFO. You can do that too. I don't know if you probably did this in algebra too, because I think they did that because I asked them to do that. Vertical stretch by a factor of 3, right? So whenever you say by a factor of, this number should always be greater than 1, always. If it's not greater than 1, you got to flip it, okay? Because it's like a vector. You're telling me if you're making it bigger or smaller by some factor bigger than 1, okay? Well, 3 is bigger than 1, so we can leave it. It's vertical stretch by a factor of 1. Now we go up into the exponent. What does the negative in front of the x do? If your x values switch, no, just think about your x values switching signs. +3 and -3 interchange. How do x values interchange? Across the y-axis. Yeah, that's a y-axis reflection. So it's really the opposite if you want to think about it that way. If it's in front of the entire function, in front of the y values, it's an x-axis reflection. If it's in front of the x's, it's a y-axis reflection. All right. And there's a 1 there, so there's no horizontal dilation. So that takes care of your dilations. You don't have to draw the line, but remember I said yesterday that these affect the shape and the orientation of the graph. And then the C and D, they affect the location. So what does the -5 do? Right 5. Yep. It's always the opposite of what it appears in the equation. So -5, you might think left 5, but it's right 5. And notice if you didn't factor it out, you might say, oh, +5, that's actually left 5, but it's not, okay? So it's right 5, and then the +4 is up 4. It's outside, so it's exactly as it appears. It affects y values. These affect the location of the graph. All right, now what we want to be able to do is to sketch the graph in one fell swoop. If you need to do it kind of as a sequence, you can do that, right? We did that yesterday. But let's see if we can actually do this as a single. No, let's not do that yet. We're not ready for that. Let's come over here to our little sacrificial graph, right? That's why we sketch it. An x-axis reflection is going to make it look like this. Yeah. So it's decreasing now, but it's below the horizontal asymptote. The vertical stretch by a factor of 3, we don't really have to show that. What that would do is it would make it steeper. So just tell yourself steeper, okay? Got it. What does the y-axis reflection do though? Well, it's going to take this result and flip it now the other way. So let me use a different flavor here. Now it's going to look like this. So that being the end of my A's and B's, this is your final shape and orientation. It's going to be an increasing function below the horizontal asymptote. That's what's important. It's going to be an increasing function below the horizontal asymptote. Then we pick it up and move it right 5 and up 4. Now, again, the horizontal shift, that's not as important because it's just going to change the y-intercept, which we're going to find anyway. But the more important of the two is the vertical shift, right? Because as we said yesterday, y equals d is your horizontal asymptote. And so because it's up 4, we know we're going to have a horizontal asymptote at 4. So now we can go to our final graph. Let me go ahead and give myself a set of axes here. The last thing we do when we're actually doing the sequence is to move it up 4, which affects the horizontal asymptote. But it's the first thing we do when we're graphing it. Now, yesterday, I put tick marks. I'm not going to even put tick marks. I'm just going to go up to 4, some arbitrary place up there, and I'm going to label it as 4. Okay, so make sure you show the horizontal asymptote. Always draw it first. If I don't see the dashed or dotted line, dashed or dotted line, you'll lose points. Draw it first. And now we come over here and we're like, okay, it's increasing underneath it, increasing underneath it. So it's going to look probably like this. But again, if you grab this with your lasso, which is really nice about notability, we shifted it right 5. So notice there is a point where my y-intercept could be either positive, 0, pass right through the origin, or if we shifted it right enough, it could be a negative value. Okay, positive y-intercept, 0, negative. So I want you to make sure you have it crossing the y-axis in the right region. So to do that, I'll always have you find the y-intercept, which is what we did on the warm-up. So for that, I always go back to the original version, okay? Because the standard transformation form is pretty useful for sketching, but the original one's usually more useful for evaluating. So let's go ahead and do that. And again, to communicate I'm doing that, I'm going to show f of 0. F of 0 is 4 minus 3 times 7 to the 5th. Now, without a calculator, I don't expect you to expand that out and get a number, right? This we could say is the exact value of the y-intercept. Great. I just want to know really if that's positive or negative. That's kind of the main thing for the graph. 7 to the 5th is pretty big, isn't it? Pretty big. A pretty big number times 3 is even bigger. So now I have 4 minus a really big number. Is that positive or negative? Negative. What did we say? Negative?
Yes.
Negative. So I'm just going to say less than 0. Look at the way I drew it. Right now I have my y-intercept where? I have a positive y-intercept. Holy moly smokers. Good thing I caught it, right? So I'm just going to either redraw it or shift this dude over. As long as it's negative. Again, the scale doesn't have to be perfect. I'm not going to judge you that way. Okay, so right there, that's a negative number. And as long as I could see your exact value of the y-intercept above, you're good. You don't even have to really label that, as long as it's crossing in the right region. And then I'm going to come back and put arrows on the end of my graph. And I'm going to call it a day in terms of the graph. That's really all you have to show. Now, everyone look at that and say, yeah, that looks 3 times steeper than the original parent function, right? Yeah. So we don't really show the steepness. We just describe it in our sequence of transformations. Okay, so now that we do that, we can find the domain. So our function's name is f. So d sub f is what? All real numbers. Yeah, the range of f is? Yeah, y epsilon, if you're doing interval notation, right? Negative infinity up to 4, and 4 gets a what? A beefy bracket or a wimpy parenthesis? You didn't say wimpy. I get it. That's fine. It's just a relative term. Parenthesis, right? Or you could say the set of all y's such that y is strictly less than 4. Yeah, I mean, what else can we say about it? Everything else that we've already talked about. The parent function of e to the x. This function is monotonic what? Growth, right? So monotonic increasing, we would say, or strictly increasing. Either one, they're interchangeable. Monotonic increasing over its entire domain, which is all our numbers, or strictly increasing. All right. Cool. You got it? Oh, it says to describe the end behavior. Let's do that. We'll take the limit as x goes to negative infinity of f. And we'll take the limit as x goes to positive infinity of f. Now, once you have the graph, it's pretty easy just to look at your graph and get the answer, right? What would be the left end behavior? Negative infinity. Or what? dne. And what would the right end behavior be? 4. Good. It's approaching 4. Yeah. Yes, it gets infinitely close to 4 from below.
It's like it's trying to climb a rope to get to somewhere, but like the last little bit has been greased, so you can't get a hold of it.
But it always makes progress.
Yes.
Yeah. Yeah. So that's what's interesting here. That's what's almost counterintuitive, that it's increasing forever and ever and ever. It's going up, up, up forever and ever and ever. It's never not going up, but it's never going to get to 4. It's like right in front of it, but it just can't get there.
It's like a dog on a treadmill chasing after a bone. You know?
Yeah, well, maybe, but on there, the dog's not moving. He's staying physically stationary, but
Yeah, but he like running along, like forever trying to get the bone.
but imagine him actually making gains towards the bone forever and ever, but never reaching it.
It's like those movies where the hallway is like infinitely long.
Kind of, yeah, yeah. You keep walking down the hallway, but the house ends. There's a backside to the house, but the hallway is infinitely long. That's better because now
It's like some SCP type stuff.
it's really hard if you think about like I'm walking towards that chalkboard back there because I'm eventually going to reach it. Watch this. Are you impressed? I reached it. Okay, I reached it pretty quickly. But if you want to think about making progress and never getting it, that's when you have to start thinking about half the distance, right? I'm going to go halfway. Boom. Now I'm going to go halfway. Boom. Now I'll go halfway again. If I keep going halfway, will I ever reach it? No. See? So that's kind of the paradox. It's known as Zeno's paradox. If you want to look it up, Zeno's paradox. Yeah. I think he describes the paradox in a race between Achilles and a tortoise. It was, I think, before the rabbit and the hare. But anyway, yeah. All right. Comments or questions on that? No? Okay. Let me give you one to try on your own. Okay. Let me insert a page here. Insert a page. There we go. Add a page. Try this one on your own. Don't try, do this one on your own. Sketch. Let's see. Let's call this A of X for Achilles of X equals, let's do A of Z. No, let's do A of X. Okay. Let's do 5 plus 3 to the negative 4 minus 5x. There you go. Okay. I'll give you a couple minutes to do that. Have a good time. All right. The first step here is to make sure we'll identify the parent function, right? Which is 3 to the x, which is growth again. But to get this one in standard transformation form, there's a little bit more involved. The 5 in the front goes to the back. Once again, I'm going to do the exponent part in 2 steps. I'm going to first put the x term first, and then I put the plus 5 at the back. But now, to get it into standard transformation form, I have to factor out not just a negative, but a negative 5 from both terms. And the first term is going to be easy. When you factor a negative 5 out of a negative 5, you're just left with 1. So it's 1x. But what do you get when you factor a negative 5 out of a negative 4 if it doesn't go in evenly?
4/5.
You get a positive 4/5. Yeah. So remember, yeah, 0.8. Remember that factoring out is dividing out. So if you need to go off to the side and say, okay, I'm starting with the negative 4 and I'm dividing out a negative 5, what does that equal? Well, a negative over a negative is a positive. You get 4/5. Okay. So it's plus 4/5. It doesn't have to go in evenly. It's what you started with divided by what you factored out. And of course, you know it's correct because you mentally redistribute. You check yourself before you wreck yourself. You get negative 5x. And then, of course, the 5s divide out and you get negative 4. So it's good. So let's just talk about what the sequence is here. We don't have time to write it out. There's really no, there's nothing in front here. So there's no vertical stretch or no x-axis reflection. There is a y-axis reflection and a horizontal what by a factor of 5? Is it a horizontal stretch or a horizontal compression? It's the opposite of what it appears. It's actually compression, right? So it works for the compressions as well as the shifts, right? You think, ooh, 5 times wider, right? Because it's 5 times, but no, it's 5 times narrower. So it's a horizontal compression by a factor of 5. And that takes care of the shape. Then it's left 4/5, opposite of what it appears, and then up 5. Okay, so if we sketch it, the first thing we do is we go up 5. So up 5, I'm just going to call this 5. And I draw that horizontal asymptote. Now, let's think about what the shape's going to be. If the shape was originally like this, right? There's the X and Y axis, and I reflect it across the Y axis only, it's going to look like this. So now it's decreasing above, right? Decreasing above is going to look like this. Now, for this type of problem, is there any doubt that it's going to cross the y-axis above the horizontal asymptote? Or in positive land, I should say. No, because it lives above the horizontal asymptote, which is in positive land, there's not that issue of me having it cross up here or at the origin or below. I know it's going to have a positive y-intercept. It has to, okay? So I put arrows on the end, and then if I wanted to find the y-intercept, a of 0 would be 5 plus 3 to the -4th, right? Well, that's the same as 5 plus 1 over 3 to the 4th, which is a really small number, right? 3 to the 4th is 81. So it's 5 and 1/81, if you want to think about that. The domain is all real numbers. And what's the range? Everything strictly above 5. Okay. So I wanted to make sure I worked a problem like this where you have to factor out on the inside more than just a negative, because there are problems like that on the worksheet. It's what you started with divided by what you're factoring out. Do it off to the side on your workbench, right? We haven't been on our mathematical workbenches in a while. Okay. You know what else you could build on your mathematical workbench? Math toys for all the girls and boys at Christmas time, like an elf, like a math elf. All right. Y'all have a super duper rest of your day. Get started if you can on your story. Look forward to reading them.